Okay, we are live, I guess. Let me check with my mobile device. Still not live. Okay, we are live. Go, let's go. Let me turn on the comment section. So, hello guys, and welcome to my live. So, yesterday, we learned about RAG, we learned about MCP. Also, we saw some ML fundamentals, for example, regression and etc. Right? We also saw some system design manager usually asks for. So these are the points we did go through. Uh, then after that, we were here in the phase part C, the senior tier transformer architecture internals. So in plain English, it is what's actually inside the brain and how every word looks at every other word to work out the meaning. So let me understand it again. What actually inside the brain, how every word looks at every other word to work out the meaning. Okay, let's see. So frequency of this question being asked in interview is 4 out of 5 and real world use is only 2 out of 5 and difficulty is 5 out of 5 means it's difficult to understand and priority is 4 out of 5 means it's very high potential to be getting asked in the interview. You've been studying this, seniors are expected to explain the machine, not just the use. Okay. So basically, it is saying that seniors are expected to understand the core of the AI, not just implementation part of it. Let me also, I just have to change the scene. I'm trying to open an application which lets me control my stream. It is called a StreamPad, which I developed in this live stream only. Not in this, but you can go in the previous streams and you can see. I just have to open that application. Where is that? Users. Documents, GitHub, impact, distribution, and then stream.py. Okay. Now I can show you my screen. Basically, this application let me control my streaming using my phone, right? Just I have to scan this QR into my phone, and after that I can actually work with it. Okay, it shows my camera is off. Let me check. It's on. Now it is off. Now it is on. Okay. Okay, let's go. And also split view and open the YouTube app. Okay, so currently nobody is watching us. We can do anything. self-attention the core of it. Every token is projected into three vectors: a query, a key, and a value. To decide how much token A should attend to token B, you take the dot product of A queries with the B key, A into B, okay. High dot product equal to high relevance. You do this for all pairs, giving n into n score matrix, scale it, softmax it, and softmax it to way. Oh my god, what is this language, bro? You have to understand in Geek for Geeks, I guess. Transformers in machine learning, architecture internals. Transformers is different. Let's move okay, this is a good explanation, I guess. So what is transformer? Okay, what is transformer? Is a core architecture behind modern AI, powering models like ChatGPT, Gemini, introduced in 2017. It revolutionized how AI processes information. Same architecture is used for training on massive dataset for inference to generate output. Here we use GPT-2, smaller, simpler, and newer ones, but perfect for learning fundamentals. Okay. This is some kind of visualization. This is embedding data visualization, empower user to. Okay, this is basically chunks of the embeddings. Let me go to next slide. Transformers aren't magic. They build text step by step by asking what is most probable next word that will follow this input. Here we explore how a trained model generates text. Write your own text using example, then create generate to see action. If model isn't ready yet, try another example. Okay. I didn't understand anything. Okay. Let's see transformer architecture. Transformer has three main parts. Embedding turns text into numbers that we understood from the last stream. Transformer blocks mix information with self-attention and refine it with MLP. Let me search the full form for MLP. Multi-layer perception is a type of artificial neural network consisting of at least 3 layers of node. Okay. So artificial network consisting of at least 3 layers of nodes, meaning like this is node 1 layer, this is 2 layer, this 3 layer, whatever, like this the diagrams are, right? I don't know about it as much, but I understand what layering means. An input layer, one or more hidden layers. Okay, let's see more on this. Multi-layer perception MLP is type of artificial neural network consisting of at least 3 layers input. My god, my ADHD probabilities determine the likelihood of each. Okay, this I understood that LLM basically predicts the next word, and that is coming from the probabilities. But I didn't understand this second point. Transformer blocks mix information with self-attention and refine it with MLP. Okay, I somewhat get it. Let's see. Before transformer embedding, I know, but let's read it again. Guys, I can see you guys. comment down below where are you from, what are you learning, are you learning the same thing I am learning, and if yes, then do comment what I am doing wrong here. Right. Before a transformer can use text, it breaks into smaller units and represent each and as list of. This process is called embedding. The term can refer to both processor and resulting vector. In this tool, each vector appears as a rectangle. Okay. Oh, very nice. So when I click on this, data. Hello, sir. Hi, Amrit Shinde. Where are you from? Amarjeet Shinde, not Amrit. Amarjeet is kind of Punjabi name, and Shinde is like a Maharashtrian surname. Amarjeet Shinde. Hello, brother. Where are you from? Tokenization with token embedding ID 660132 plus the position of it. I'm BTech third year current and I don't know see about coding. Which language should I start to learn? And no, I am from Pune, sir. So brother, I think you should not care about the language because in real companies they don't really care about language. Yeah, initially they do. So initially they do, but it doesn't really matter because, for example, in full stack development you have to work with Node like JavaScript language. You will work with Node project. Sometimes you have to work with C# project with if there is a need. You may have to work with Python. For example, you want to create a like a NLP server, a coding, not coding, but a server which is used for agentic work. Then you will have to work with Python. So previously Python was not used as much, but I can see a boom of learning for Python. You must be having this language in your syllabus as well. So I think if you are like just preparing for it, you can go with Python for now, but you should not care about you choosing the language. You can choose Java, you can choose Python, you can choose JavaScript. The main concern companies search for is basically you can do problem solving. Full stack Java, I'm thinking. Okay, yeah, you can do it, man. You can do it. You can do Spring Boot and stuff. Actually, I was a Java developer when I was in my post graduation. But later, when I joined the company, there was no use of Java, and they wanted me to learn JavaScript, and I did for a week or so. I did some training on JavaScript, and then I started doing work. So this will happen to you as well, and this happens to other as well, that they initially thought they will be working with some single language or something, but this doesn't happen in real life. They have to learn a new technologies every day. You have to work on new frameworks every day. For example, someday for example, you are a front-end developer, and there is a new framework that has come out. You will have to eventually going to learn that, because eventually companies going to implement those frameworks in your system. So think about it that no language is bigger than you. You have to like think that this is easy for me to learn. The same way I'm learning right now. I think some of the topics are difficult, but I should be like confident about it that I will eventually get to learn this. Right? I know I have done um, implementation of AI systems in my existing company, as well as I have created my own products. For example, if I open my portfolio, you can see my projects. Right? I have created some very nice websites which actually has a lot of users. I have agentic browsing extension. I have some more projects, some projects which I have not even listed here. So I have AI experience already, but I'm still learning about it. So every day I have to learn, man. Like in Sundays also I'm streaming and learning. Okay, for example here, data visualization empower users to create and. Okay, so this and word got generated, I guess. Yeah, because the probability was highest of and. Second highest was comma. Third highest was A.
Hey Spotifyers, wherever you're headed, make sure
My
you've
Spotify
got the right
subscription
travel companions.
is.
A playlist for your
Oh my god. Okay, I have to, I guess, renew my subscription. Meanwhile, I can play in YouTube. Lo-fi royalty free music. Let me see if auto plays on. I guess it is on. Okay. If you guys have any question, do ask me. What is token embedding? Let me lower the volume. Tokenization splits input text into token. Small units like words or part of word, like in GPT-2, which is small LLM, has 50,000 something token vocabulary, each with a unique ID. In token embedding step, every token is matched with 768 number vector for large lookup table. These vectors are learned during the training to best represent each token meaning. Word order matter in language. Positional encoding gives. These are some of the topics like you will learn once and you will forget it next day. You will understand it today, but you will forget it tomorrow if you don't like relearn it again and again. Okay, we'll do it again and again. GPT-2 does this by adding a learn position embedding. But newer models may use other method like rope, which. What is rope? Rope processes 2-dimensional. So this is used for basically ordering the words. Alternatively, it can refer to Ropes AI, a tech platform focused on candidate skill and identifying a rope. This is wrong. This concept I know. A technique that applies geometry rotation of queries and key vectors in attention mechanism on a token absolute position. Let's see in Hugging Face. Rope, when AI finally learns where it is, finally giving GPS to words in your model. Okay. Basically, how to assign the position of the words to make a sentence. Your AI understood the cat eats the mouse and the mouse eats the cats, but as the same sentence, because it will get broken into chunks as a token. Okay, now row, it finally gets the order that matters. Principle, position awareness, each word knows where it is. Rotation magic, we rotate factors in mathematical space. Welcome Amarjit, sorry, again I told you as Amarjit Shumis. Brother, do come in next stream also. Do subscribe and like. I am here, we'll learn together. Position awareness, each word knows where it is. Okay, rotation magic, we rotate the vector in mathematical space. Relative distance, understand close versus far in the sentence. Extrapolation works on the sequence longer than training. Zero extra parameter to train. Okay, zero extra parameter is just trigonometric calculation. Natural extrapolation trained on 2k tokens works on 32k plus. Okay, intuitive understanding of relative distance between words, backbone of modern LLMs, Llama, GPT, Claude uses. Okay, computational efficiency, no parameter to learn. Sign cost for each position, CPU cost. Okay, understood. Memory cache can take several GBs for very long sentences. Okay. Base theta not optional for all domains. Performance degrades far from training length. Okay. Harder to implement than simple position embedding. Implementation is the farther from the training length, the less reliable. Okay. Optimal parameters vary. Code versus chat versus academic. Rope cache can be used, for example, GPT-4 equal to several GPs. Okay. No infinite improvement. Extrapolation works but with limitation. Specific optimization needed for production. Let me lower the volume of this music, man. It's too loud. Also change the music. Okay, test 512 token perplexity equal to 12.33. Okay, we'll jump back to our own thing, what we were learning, positional encoding. Word order matter in language, right? And that word order is basically done by rope. Positional encoding gives each token information about its place in the sequence. GPT-2 does by adding a learned position embedding to token embedding. But newer model may use other method like rope, which encode position by rotating certain vectors. All aim to help the models understand order in the text. Okay, this I understood. Repetitive transformer block. Okay, it is asking me to click here. I'll click here. Okay, this is the first transformer block. The same thing, but second time also. Okay, there will be third time, fourth time. There are, I guess, okay, this many numbers of identical transformer. Okay, it is doing the same thing. Okay. Let's go back to first transformer block. First. Transform block is main unit of processing in the model. It has two parts: multi-head self-attention. Let's token share information, and MLP refines each token details. Okay. We understood that MLP is used for refining each token, but I'm still not clear how it does it. This type of artificial neural network consisting of 3 layers or okay, an input layer, one and more hidden layers, and an output layer. This I understood. Okay, starting one will be input layer, last one will be output layer, and in middle there will be a layer again which will be hidden or visible. Each layer is fully connected to next, meaning every node is a layer in a layer has weighted connection to every node in the following layer. Unlike simpler models like single layer perceptrons, MLP uses non-linear activation. Sorry. Unlike simpler models like single layer perceptrons, MLP uses non-linear activation function. Example: ReLU and sigmoid. Sigmoid was used for classification that we remember from the last stream. But what is ReLU? Rectified linear unit. It's popular activation function in deep learning defined as fx equal to m0, x. Okay, it passes positive numbers straight through and changes negative number to 0. Okay. Formula fx equal to m positive. Okay. Let's go to geeks for geeks to understand better. ReLU is widely used for activation function in the deep learning that outputs indirectly if it is positive and returns 0. Otherwise, its simplicity and efficiency makes it difficult choice for the next. Okay, we'll go back to our own learning of repetitive transformer blocks. Multi-head self-attention. Self-attention lets the model decide which part of the inputs are most relevant to each token. This helps it to capture meaning and relationship even between far apart the words. In multi-head form, the model runs several attention processes in parallel, each focusing on the same different pattern in the text. To perform self-attention, each token embedding is transformed into three new embedding query key value. This transformation is done by applying different weights and biasness to each token. Query key value. Okay. Once created, queries can compare each keys to measure relevance, and relevance is used to weight the values. Okay. Mm-hmm. Okay. So this will query compares with keys to measure relevance. Query compares keys for relevance, and this relevance is used to weight the values. We'll get the output here. Click to see query key value calculation. Okay. Data. Okay. That's crazy. Let me see it again. Data X is query. I'm heading into query. Biasness equal to data. Okay, I can somewhat understand here. Let's go to next topic. Click multi-head. After creating query key value embedding, the model split into several heads. For example, like 12 in GPT 2 small. First head, second head, third, fourth, fifth, sixth, 7th, 8th, 9th, 10th, 11th, 12th. Okay. Each head works with own smaller set of query key value focusing on different pattern in the text, like grammar, meaning, long range strings. Multiple heads lets the model learn many kinds of relationship in parallel, making it understanding richer. Okay. Why do it look like this? Okay. It was freezed. Let me check in the stream how. Okay, this happened when I opened the OBS. Nothing serious. Okay, that's alright. So, mass self-attention. In each head, the model decide how much each token focuses on other. So dot product is multiplying matching number query key vectors. Sum to get the attention score. Click on attention. This is dot product. Mask hide the future token so it can't be picked ahead. Convert score into possible probabilities. Each row summing to 1. Showing focus on earlier tokens. Okay. Scaling or mask. Convert score into probabilities. So highest probability is of data. Okay. Okay. By the way, this transformer explainer is like very nice, man. Very detailed, you can say, and it is like very carefully made to understand it correctly. Okay. We also have a video to understand. Let's see the videos directly. I think it's just a video of using this. Let me pause this. Let's see. Demonstrate how text generative works. Okay. Adjust temperature slider to control the probabilities of word production. Okay, they've also explained stable diffusion. This website is crazy, man. Who has created this? poloclub.github.io. Open this. What are the different scalable, interactive, interpretable? These are the people which have worked on this. Thank you, guys, man. Means a lot, I guess. Okay. Dynamic safety shaping. Exploring the multimodal literature, forging strategies. Okay. Reputation meets safety. Let me just search this one and we'll get back to the work I was doing now. Florida, concealed. Suitcase, car 33, car 77, stop sign 89, 95 car. Okay. We'll get back to our work, man. There's too much. Query key value. Query and key goes to create a weight for value biasness, and it blends and it gives the output. Hmm. Okay. We'll study till 9:30, and then we'll stop the stream, and then we'll connect tomorrow. This transformer example was very good. Let's understand it fully, and then we'll proceed to the next topic. MLP, the attention output goes through MLP to define token representation. A linear layer changes embedding values and size, and using learned weights and biases. Then a non-linear activation to decide how much each value passes. Many activation types exist. GPT-2 uses. My God, every new topic we learn, we'll have to learn a new topic again and again, man. What is this Galu? This fucking gay shit, man. Galu. Gaussian error linear unit. No, man. What the heck? A high performing non-linear activation function used in modern Galu. Make me understand like I am 15-year-old. Galu. Imagine you are building a smart brain for your computer. To help this brain make decisions, it uses a thing called activation function. Think of this a light dimmer switch that decides how much information to let through. Oh my god, now I can understand. Is my brain is like a 15-year-old. The Galu, a Gaussian error linear unit, is just a really smart dimmer dimmer switch which used in famous AI models like ChatGPT. The goal is filtering information, how much information it should come in. Okay, when computer brain processes information, same data is useful. Okay, the positive numbers, and some is useless noise. Okay, those are negative numbers. Old way, ReLU. Okay, ReLU was old way. Old AIs used us. When we learned about ReLU, it said that modern LLM use ReLU. Now it says GeLU is used. I think we'll proceed to next topic, and then there will be again a new Lu, like Telu, and it will be said as Gelu is the old way and Telu is the new way. Old AI uses switch that acts like a regular wall switch. If data is positive, it let it pass. If it was a negative, it flipped the switch completely off to zero. The problem: sometimes small negative numbers actually contain useful context, and turning them off makes AI blind to certain patterns. The Gelu. Gelu uses smooth dimmer switch. Instead of cutting off negative number instantly, it drops them gradually based on coin flip probability. Very nice. But switching like dimmer is a smoother one. Okay. How Gelu works? Playground analogy. And don't go to playground. Man. Why Gelu is a big deal? No dead brain cells because it doesn't completely freeze every negative inputs to zero. Okay, that we understood.
Yeah.
The computer brain keeps learning from every path. Okay. Smoother math. It creates a smooth curve which makes it easier for AI to adjust and learn during the training process. Powering giant. It is a secret sauce inside transformer models, meaning tools like GPT-4 and BERT. Now I have to understand what is BERT. BERT is a machine learning model for NLP created in 2018 by Google. It reads words in both directions at the same time to understand full context of the sentence. Okay. You can explore checkpoints and tools via Hugging Face. I think BERT is a dead NLP. Okay. It is saying powering giants, but I don't know BERT is even there in the giant thing. Maybe it was in some time back, but not right now. Okay, so we understood GALU. And where were we? Here. Many activation type exist. GPT uses GALU, which lets small values pass partially, which we understood currently, and large values pass fully, meaning like positive numbers, helping capture both subtle and strong patterns. Okay. All transformers blocks the last. Let me click on this. So this part is GALU thing. What do I think? Click to see MLP process. I don't want to see MLP. This whole part is GALU, MLP. I asked question what MLP does, but I think this is the taking result thing and doing GALU. Okay. GALU. After all the transformer block, the last token output embedding. Okay, this one. Crazy. Scale logic, top-tip filtering, and softmax. Okay. Softmax. Let me see the attention again. Dot product. Scaling or masking. Use softmax for the weight of the value. And then GALU. And then okay, adding all this gives 36%. Okay. Data visualization empowers user to create. Comma is also a very nice, not very nice, but comma is also a good option after a create. Okay. Data visualization empowers user to create. Is also good. User to create interactive. User to create there. User to create visual. User to create custom. Okay. Okay. But now it will give and okay. After my name is okay, after the A. Why didn't it select a little instead of it selected bit? Okay. So I'll choose little. What after little? This produces logits, 50,000 numbers, one for each vocabulary, that indicates how likely each token is to come next. The logits are just raw scores. To make them easier to interpret, we convert them. Let me go to next sound. Instead of always picking the highest probability token, we can use a different selection strategies to balance safety and creativity in the generated text. Temperature works by scaling logits that can display. A lower temperature makes the large logits even larger, and the smaller ones smaller, favoring the highest scoring tokens and leading to be more predictable choices. A higher temperature, 1 or above, flattens the differences, making it less likely tokens are more competitive and leading to more creative output. If I go after 0.8, let me go. My name is Little. Little bit. Little bit different. Dot. I am. I'm not sure. Yeah, sure. If I can interrupt to 12 words. Okay, I understood temperatures. Finally, we need a strategy to pick the next token. Many exist, but there is a common one: greedy search pick. Top K keeps only the K most likely tokens. Top P keeps the smallest set whose total is probability is trimming unlikely ones. Then softmax turns remaining logits into probability, and one token is picked from the random. Top K is similarity 1. What is top P? Top probability. Okay. The transformer have auxiliary feature that enhances the model performance. For example, residual connection add a layer input to its output, keeps information from fading through many blocks. In GPT-2, it used twice per block to train deeper stack effectively. Okay. Second last one, layer normalization. Here and here. This is the second transformer block, I guess. No. This is part of MLP before GALU. Layer normalization helps stabilize both training and inference by adding input numbers so that mean and variance stay consistent. This makes the model less sensitive to its starting weight, and it helps learn more effectively in GPT-2. It applies before self-attention, before MLP, and once more before the final output. Input numbers so that mean and variance stay consistent. This makes the model less sensitive and to starting weights and help it more. Okay. Dropout. During training, dropout randomly turns off some connection between numbers so the model doesn't overfit the specific pattern. This helps it learn features that generalize better. The users, but neural often skip it because they train on used dataset and overfit is less problem. In inference, dropout is turned off. Okay. So we understood this. Know the modern answer. This we understood. Rest of the block. Add a norm feed. Okay. Replace a single FFN and many FFNs plus router that send each token top. We understood all this. Okay, so we'll learn next topic tomorrow. Okay, which is inference and serving optimization. Yeah. Yeah. We'll learn tomorrow. Thank you guys who was watching us. Thank you so much.